Well, thank you everybody. First of all, thank you everybody for coming to our world talk. We are going to talk about an open source distributed data generator that we have created in Stratio. We gave this same talk, a couple of weeks ago in Miami in the Apache Big Data conference, and that's basically the same presentation. Well, this is the agenda for today's talk. We are going to talk briefly about who are we, and then we will be talking about why we have created this tool at Stratio and what it is. Then we'll walk through the technical details of the tool, and then we'll see some use cases that we have worked with in Stratio. And then we'll see some features that we would like to implement in the future, and then hopefully, finger crossed, because we've had some problems, we'll see a live demo. Okay, so this is me. My name is Alberto. Well, after graduating, I've been programming for around 13 years, several companies, several sectors, aeronautics, telecommunications, public sector in Spain as well. I also work abroad in Ireland and in London, and well, these are some of the technologies that I've been working on the last years. I've been mainly programming Java, but the last years I've been programming in Scala, and well, working with Kafka. I'm a Apache Spark certified developer, also working with Play, Akka, and so I'm also a Apache MetaModel project committer and PMC member.
Well, hi everyone. This is me. My name is Emilio. Well, I'm sorry, but my CV is not so good than Alberto. During the last 10 years, I have been working in several projects with Spanish banks. Well, this is some of the skills that I have been involved in the last years, and mainly as Java developer, but the last 2 years I have been working with Scala.
Cool. So, well, where are we working right now? Well, we work for Stratio. Stratio is a Spanish startup that is building a data-centric platform, and well, we are building. We'll see a slide in the next slide, but we are building a platform on top of Apache Mesos, on top of DCOS, and well, we are multi-persistence. We work with a lot of persistence, and we are also building some modules around the persistence, around the data, to try to fulfill all our clients' needs. Well, this slide is a little bit overwhelming, a lot of stuff in here, but basically we are building we call it Stratio EOS, Enterprise Operating System, that is, as I said, is based in DCOS Common. DCOS under the hood is using Apache Mesos to deploy the services, and well, we are also building some modules around all of this stuff, such as Stratio Sparta, which is a real-time evaluation system, Stratio Cross Data, which is a SQL query engine, and so on. We have multi-persistence, and our aim is to build kind of a microservices layer on top of all this stuff to help our clients to fulfill their needs. Well, let's have a look at what is Khermes and why we have created in Stratio. This is a little bit of literacy about the name of the tool. Well, Khermes is the god of transitions and boundaries, so we thought that it would be good, it would be cool to call our tool Khermes, and we added a K in front of the name because we use Kafka as our main backbone. Well, we have created the tool in Stratio. But as I said, we are building a data-centric platform. So obviously, data is a must for us. So from the beginning, we have building a lot of modules that obviously need data to work. We built an ingestion module. We built a real-time migration module. Another module was called Stratio Streaming that somehow perform some kind of complex event processing operations with data. So the data has been a must throughout Stratio's life. So also our clients come to our office and they wanted to see the platform working. So we needed something that's great data to ingest the data in these modules and to see that our stuff was working fine. And also we needed this data to measure the performance of our components. So we created a code that we call Fakenator. That was like a proof of concept. We created in, I think, 1 week. And has the following limitations. The tool was intended to, when the clients come to Stratio, we used to show a retail demo. We simulate a real retail company where people purchase stuff around the world, and we generate the tickets, the things that the people was buying around the world. So the data generated with this tool was very coupled to this demo. And also every time we need to modify a field, we need to add another field, or we need to modify the data that we were generating, we need to modify the code, and was kind of pain in the ass. And also it was not ready to be executed in a distributed fashion. As Stratio was moving to a distributed environment, like DCOS, we thought that it was cool to create a new tool that was able to be executed in a distributed environment. So taking these facts into account, we've created Khermes. So these are the main goals of the tool. We wanted Khermes to somehow easily generate user-defined dynamic data. We wanted a broad catalog of data generators. The users can generate, we'll see in a minute the generators that we have already created. It was designed to run in a distributed environment, easy scalable, in this case through Marathon. We'll see at the end of the demo a video of Khermes working in DCOS, and we'll see how easy it is to scale the application, to scale up the application through Marathon. And then an API to configure and modify its behavior on the fly, and this is on the roadmap, and we'll see the first steps, friendly user interface. Okay, so Emilio will talk about the technical details.
Well, as Alberto has said, this is the main technologies, the main components that Khermes is composed of. Aga cluster. Well, the main goal of Khermes is to produce huge amount of data. Depending on your needs, you may need to produce data, more data or less data at a time. So we need to create a tool that be able to increase or decrease easily. So we thought that Aga cluster with its node could be a good idea, because you can increase or decrease the number of nodes in your cluster, in your Aga cluster, and increase or decrease the number of messages at a time. Next, Kafka and Kafka Connect. Well, once your messages are produced, you need to transport them. So we thought that Kafka is your best friend. So, and depending on your needs, if you want to store your messages in some data store, you will need to set Kafka Connect with the appropriate connector, depending on if you want to use Cassandra or any data store. Finally, Zookeeper. Using Khermes, you need to set some configurations for the different components. So we are using Zookeeper to store that configurations, and when you need to restart your instance of Khermes, you don't need to set again all the configurations, so you can recover the configuration from Zookeeper. Aka cluster, as I said before, this is a diagram of the Gossip protocol. Gossip protocol allows the nodes to auto-discover. You run firstly a seed node, and the next nodes are simple nodes. So with the Gossip protocol, you are able to auto-discover all your nodes in your cluster. All of them know each other. So when some node is down, all the nodes know it. So you can know every time all your nodes status. It's fault tolerant and no single point of bottleneck or failure. And as I said before, is next Apache Kafka. As I said before, is your best friend for transport a huge amount of data, and actually currently we can't say anything that you already know about Kafka. In our demo, currently we are using only one broker, but depending on your needs, you can run the number of brokers you may need for increase or decrease your performance. Kafka Connect, as I said before, this is not a mandatory component. Depends on your needs. So if you only need to transport the messages to Kafka and then run a common Kafka consumer console, you don't need to set any configuration for Kafka Connect. But if you need to transport the messages to any data store, you may need to set up the appropriate component, the appropriate connector. This is an overview of Khermes. As you can see, this is a 5 nodes cluster. One of them could be the seed node, and all of them, the rest nodes, sorry, are simple nodes that are auto-discovering each other. All of them, when you start producing data, all of them are generating data. You can set different configurations, so you are able to produce messages using one template, and other nodes could be able to produce messages using another template. Zookeeper for storing your configurations and be able to save and load for next runnings. And over there, Kafka cluster. As I said before, you only need one broker, but if you need to increase the number of brokers, you just run the brokers you need. And Kafka Connect depends on your needs and the appropriate connector for your data store.
Yeah. Cool. So how can you guys start playing around with Khermes if you want to go home and then start playing around with your tools? So we've prepared. We also put quite effort in the documentation of the project. There is a wiki page. So well, I think it's in the last slide. We have created I think a cool documentation with all the steps to start up Khermes in these three ways. The simple one is the Docker way. So we've created a Docker Compose file, so you can go and just execute Docker Compose, and everything will start up for you. As we'll see in the demo, it will start the same environment that we'll see in a minute. You can also start up Khermes as a standalone project. This is is implemented in Scala, so you can just go and do a Maven clean install, and then it will create a jar for you, and you can start seeds and nodes, and as Emilio said. We've also prepared some scripts to simplify this task, but it's very good explaining in the documentation. And the DCOS, well, we've tested in our labs in Stratio, and you can also deploy it as universe application.
Okay, well, so here you can see the main commands that Khermes is providing you. Here you can see our web-based console. We have developed a web-based console based on WebSockets. So using WebSockets, this console connects with our web backend, and you can run all your commands from your browser, and then we'll be connect with our backend. Here is, as I said before, the main commands. Well, starting with Kafka, as you can see, you just need typing in our web console the command create Kafka config, and the prompt asks you about a name that you want to set for your config, and then you can copy paste your configuration to set up the Kafka instance. As you can see, this is some of common properties of Kafka. You can paste the typical properties of Kafka, so the command will be able to parse all the properties. Here we are setting bootstrap servers, and as we are using Kafka Connect, we need to set up a serializer for connect with Elasticsearch. We need Elastic in our demo. Well, the templates. We are using templates, Twill templates from Play framework. Twill allows you to set up your own custom message. You can define all the fields you need for produce your message as you want. Here is an example that we are using in our demo. Is similar to a JSON, so you can see the fields, and we are defining in Khermes different random generators of data. So we are generating here in our example a fake played song, simulating that you are listening different songs from different places. So we have the typical fields such as song, artist name, the album, the play duration. We have defined also geolocation random generator, so we are simulating that the songs are reproduced in different locations from USA or Spain. Also, you are able to type in directly Scala code that will be compiled when you start Khermes. If you need some documentation, you can see the Twill from Play framework, and then you can see more details. Well, generator config. Here is common properties for Khermes. As I said before, twill templates needs to be compiled at the runtime. So firstly, when you run Khermes, at the first moment, all your template will be compiled. So you need to define some place where the class files will be located. You can define the topic of your messages. So here we are setting the topic Khermes, but you can define different configurations using different topics. So when you are running and producing messages, you are able to set different configurations for different nodes, and you are able to produce some kind of messages using some nodes and other messages using the other nodes. And all of them are sent to the topic that you set up in the configuration. Also, we thought that it could be a good idea to define different rules. For example, you may need a maximum number of messages. You can set up the maximum number of messages and set the stop rules. Or maybe you may need to start producing messages, stop during 10 seconds, for example, and then continue producing data. This is some of rules that we are defined for this example. Well, Abro config. If you need to transport all your messages to any data store using Kafka Connect, you also need to set Abro and define the structure of your message, setting the different types of your fields. This is not mandatory, so if you don't need Abro because you don't need to store your information in any data store, you may leave this configuration blank, and the tool will start without any problem. And once you are defined and set all the configurations, you are able to start Khermes. You can list the nodes of Akka cluster. As you can see, currently we have four nodes, and the status is false, so they are waiting for starting producing data. And then you can type the start command, and the prompt will start to ask you about the name of configurations that have been stored in Zookeeper you want to use. So for example, we want to use a twill template called T1, Kafka configuration, generator configuration, Abro configuration, and finally you are able to define the nodes that you want to start producing data. Here we are setting only one of the nodes, but if you leave blank the last command, all the nodes will start to produce data. Use cases?
Cool. Okay, so we'll see some of scenarios where we've been using Khermes at Stratio. So as I said at the beginning of the presentation, the first one is as a producer for our clients' demos. So here you can see some of our modules, and actually these modules needs some data. So we use Khermes to produce this data. In this case, well, we are producing data to Kafka. We configure Kafka Connect, putting the data in any data store, and well, we're using Spark for some batch processing, Stat Intelligence, that is our kind of machine learning module, and that we also created in Stratio, cross data to query the data, and well, Stratio Viewer, that was our visualization tool for visualizing data. So Khermes is our source of data. Well, we've used Khermes for some data ingestion. Sometimes the clients know data, but they didn't have already the data. So it's quite useful to start producing fake data and start ingesting the data in the persistence and start working with the data. So we can give the clients quick feedback of what's going to happen with the data and how the system will behave. And also we've used Khermes as such kind of a stress tool, combining with some monitoring tools that we'll see in a minute with some Grafana dashboard and so on. We are, we were able to produce some kind of monitoring tool with a dashboard that have helped us to measure the performance of Stratio EOS. Okay, so this is basically a sum up of all the talk, as this is the feature that we have implemented already. So we have an Apache cluster that help us to produce data. The nodes can produce data in different Kafka topics. The data is configurable through the templates that Emilio has talked about. We've got communication with WebSockets between the front and the backend components. We've implemented these random data generators. This obviously can grow till infinite. We've implemented data generators for numbers, names, geolocations, timestamps, emails, and music generation for our demo. The names can be generated in English and in Spanish. We've got different locate files, so you can generate names in English and names in Spanish, which is cool. We've integrated with Stratio Enterprise Operating System, as we'll see in a minute as well. And well, we've created a web console and a simple cluster interface. Features to come. Well, we can generate more and more generators. We've have partially implemented weighted generators. Let's say that you want to produce in a field, you want to produce male and female. You can say, okay, I want 80% of males and 20% of females. So this kind of things you can do that already with Khermes. Obviously, we would like to improve our user interface. We'll see in a minute. It's pretty basic. Colleague of us in Stratio have created a very simple interface that basically shows the status of the cluster and shows which nodes are producing data and which nodes are not. So we would like to improve it a lot. We would like to see how the data is flowing through Kafka, even to watch which topics is flowing, which is the throughput, the configuration, current configuration. So a lot of room to improve over there. We would like to get rid of the hyper dependency that Emilio has just told. Maybe using the ACA persistence features, I don't know, we would like to get rid of this dependency. And well, a cool feature could be just to connect to a data store, discover the schema, and just start ingesting data for this data store. This could be fun. Okay, and then finger crossed, we'll run the live demo. This is the environment that I talked about at the beginning. So you guys go to the documentation and download the project. This is the environment that you will get for free. So we start a cluster of Khermes with I think 3 nodes on 1 seed.
Yeah.
Kafka cluster as well for you. Then we configure a Kafka Connect, a schema registry, and then we also set up a connector with Elasticsearch. So all the data that we were producing with Kafka will flow through Kafka Connect, and will will store in Elasticsearch, and we've prepared a cool Kibana dashboard to see how the data is flowing through the system and is entering in Elasticsearch. And also a Grafana dashboard to see some metrics of Khermes. And I think that's it. Well, this is the template that we'll use in the demo. It's basically the template that Emilio just talked about. So, nothing to say here. We'll be creating some people playing songs around the United States in this case, because we will be using the United States location. This is a video that we'll see. Well, maybe we can, because I have to mirror the screen. Let's see the video now. Yeah, can you play the... So this is a video that we record when we deploy Khermes in a Stadio EOS. So well, if you are playing around with DCOS, this is the DCOS universe. You can deploy like an Apple Store. You have a lot of services, a lot of applications that you can deploy in your cluster, and under the hood, Mesos will deploy it in the different agents. So a lot of configuration that you have to fill, Kappa topic, producers, and so on. And we'll basically want to show you how easily it is to scale Khermes using DCOS. So well, you can deploy Khermes. This is the Mesos interface. So you can see how Khermes has been deployed to this host. Well, this is Mesos. You can go through the sandboxes in the Mesos interface and see the logs of the services. This is Khermes. This is our viewer, our visualization tool. This is basically the same that we will see in a minute. How Khermes is generating data, and we'll see, yeah. So this is, can you pause for a minute? Yeah, it's complicated. Okay, cool. So this is DCOS, the interface. So they have integrated Marathon within DCOS. So you can go through one of the services and just set up the nodes that you want to scale to. Fill in this field, and you can scale the application so easily. So this way, we will scale in Hermes to, instead of producing in just one node, we'll produce data in 8 nodes more. So just basically for you to see how easy it is to increase the load of Khermes. And well, this is again the Mesos interface, and we've got 9 Khermes instances running.
Finally, the scale down.
Yeah, well, I think it's not worth it. As you can scale up, you can also scale down. So it's the same concept.
Oops.
You go to the interface, go to scale, and instead of 8, just scale down to 1, and then it will scale down for you. That's it. Okay.
Let's start the demo.
Vamos a hacer el mirror de la pantalla. Denme. Mirror screen. Okay, cool. Okay, so let's. You can let me start again. Okay, so this is the web console that Emilio has been talking about. This is for now the only point where you can interact with Khermes. So you can see all the commands that are available in here. You can see the nodes that are currently working. The status of all of the nodes is is false. They are not producing data. And as I said, we have created a very simple interface. I'm not sure if yes. So, how do you see it? Let me. So this is the interface that I've been talking about. Just showing the cluster of Khermes. They are, well, all the nodes are gray, so they are not producing data, and we would like to improve a lot the interface. Showing maybe at the right of the screen Kafka and the topics that are available, and when the nodes start producing data, how the data is flowing through the system. But right now it's just showing the status of the cluster and if the nodes are producing data or not. Okay, so we'll set up all the configuration for you, for not to do it during the demo. So let me show you the configuration that we have created. This is the same configuration that Emilio has talked about. So we've configured the Kafka that we'll be talking with during the demo. We've also have configured the Twitter template that we'll have just seen, the Avro config, and the generator config. For demo, I think we have not set up any rules, so it will be produced as much as messages as it can. Okay, so let's start producing data. Well, we've also prepared for you, this is a Kibana dashboard where we can see, hopefully, how the data is being ingested in Elasticsearch. And we've also have prepared, well, this is a Grafana dashboard. Here we can see some stats of the JVM of Khermes running, and here hopefully as well we'll see how the messages are the messages are being produced. So let's start producing some data. This is the interface for Landup. I don't know if you guys have heard about it. When we were setting up the demo, we had some problems with the geo points in Elasticsearch with the official Elasticsearch connector. So we were looking for another options, and we found out Landup, which is a company that have prepared kind of environment to run Kafka, connectors, and so on. And with the connector of these guys, the geopoints were working fine. So we've decided to use the Landup environment for the demo. And it's quite cool because you can create, you can see the topics in here, schemas, connectors, and the brokers. It's pretty useful. And we'll see, well, it does not work as well as so. Sometimes I think in the Kafka topics GUI, you can see the information that the topics are receiving. We'll see at the end of the demo. Sometimes it fails because I don't know if it's because we are producing a lot of data, but sometimes it fails anyway. Okay, so let's start producing data. We've got the nodes, so let's type the start command. We need to specify the template to start producing data. Let's specify the template one, the Kafka config that we've previously stored, the generator config, the Avro config, and let's start producing data with just one node. Cool. So if everything is working fine, we should see. Let me have to refresh this guy. Okay, cool. So we will see how Khermes is producing data. In this case, we are simulating songs played in the United States. You can see well. Yeah. So if we have some zoom in. So for instance, Well, in this area, there are a lot of zones played. We got some zoom in Miami, for instance. These are some locations that we've included with the project, and we're basically getting some random value.
We've got a file with different locations from the USA. So using Khermes, we are getting randomly these locations and generating the messages using them.
And this is a pie with, we've also generated the genre of the songs. So right now people are listening more dense songs that pop songs, for instance. Well, yeah, they are playing a few rap songs and Latin rock and so on. So this is Khermes generating random data for you. And in the Grafana dashboard, you can see, you can see how many messages we are producing with just one node. So this is 1 million messages. So it's performing quite well. It's just this is running in my laptop, which is start to suffering, and this is the messages sent rate, and this is the memory shades and the garbage collection. And well, in our interface, we should see how the node has changed to blue. So this means that this node is producing data. So if we wanted to increase the load of the data, well, we can start to producing data with another node. So we will go to the console. We will use the same configuration in this case. Generator config. Oops. Oh, shit. Demo effect. Okay, I'm prepared for this. Cool.
No?
Shit.
Try to disconnect and then.
This is crazy. Okay, let me mirror the screens again. Oh, okay, cool.
Yeah.
Okay.
I promise this is our first time.
Okay, I will start producing data in another node. So instead of producing with just one node, we'll be producing with 10 nodes. So we'll see how the rhythm of the messages will increase. We'll see in the Grafana dashboard that there is another node producing data. And this is the second node producing also data, and yeah, that's it. And the Landup interface, let's stop producing data. Cool. So the nodes are not producing data anymore, and we can see in the Landup interface. I don't remember where it is. So this should be a topic called Khermes, which is in here. Yes, and this is all the can you see it? I don't know if we can. So this is all the messages that we've sent to the topic. So you can see the song, the artist, the album, the genre. All this data has been generated by Khermes randomly, and these are the locations that we use in the Kibana dashboard to show the data. And I think that's basically it. We've found out when we were running the demo that our Elasticsearch connector was kind of a bottleneck because the configuration you can see here.
Although Kafka is ingesting fine all our messages, the Kafka connector is suffering a lot.
Yeah, I cannot keep up with Kafka. This is this should be maybe because of our configuration of the connector. We just
using only one.
Just task, but after stopping the messages producing, we'll see how the messages are still getting to Elasticsearch. So if we go in here, it seems like it stops. Cool. And that's basically it. And we don't have no. You have
so
questions?
that's it.
T-shirts for you. I don't know how many are there. I think we have Any questions?
I have a question. So, to your problem, what can you do about throttling? Can you do some sort of throttling to try and either stop the number of messages coming through?
Yeah.
Down?
With the rules that we have defined, we can define kind of, okay, let's produce 1,000 messages and then stop for 10 seconds and then start producing another.
So it's not use of the stops. Like
Yeah.
So say you want to produce 1,000 in 5 seconds, you use the pipeline and then sleep sort of thing.
Yeah. You can,
Trying to reproduce a real environment, because it's normally that you are not producing messages all the time. So with these rules, this kind of rules, you could simulate this real environment.
Yeah, we will maybe add more rules.
This tool is an open source tool, so
Yeah.
It's open.
So you can go to GitHub, download, and hopefully contribute with us.
Propose a pull request. Welcome.
I think it's over there. This is the GitHub of the project. Is into the wiki. As I said, we'll put quite effort in improving the documentation, so you can go and start the demo that we have done in 5 minutes. And if you want to contribute, obviously we will be very grateful.
Maybe the first time you need more time, because you have to set all the configurations, but there are 5 components.
Yeah, we have also copy and paste the configuration that we have.
Once you have your own settings, and then they are stored in Zookeeper, so the first time is a little bit more stress, but then the next times you just run Khermes and get the configurations and start producing data. Any question? No?
Thank you.
What? Thank you.
guys.